Hello there everyone. So we are mechanics. We're going to go back to the nice little fairly simple area of constant acceleration today, but in specific looking at the questions that you might get asked which centre around making a velocity time graph. Shouldn't be that tricky. There are 4 questions on Maths Genie. I'm going to do 2 of them with you on this video. I'd like you to then have a go at the other 2 as well. I'd like you to have a go at these ones before watching me do it. You can pause the video if you like, do it that way, or you can do all 4 of them and then see if you've got them all right and you've using the answer bit. And if you have, then fine, then you don't need the video, do you? But either way, you need to do all 4 of these questions, and you need to send me some evidence that you have done that. Here's the first question, so as I said, pause it and give it a go. Now, before sketching the actual velocity time graph, it's a good idea just to make a little picture of what's going on. So we've got station A and we've got station B, and we've got a train, so you can always draw a nice little choo-choo train. Right, so there we go, that's some kind of train, isn't it? But what we need to do is have this idea of the different things that's going to happen, because there are 3 stages to this journey. So for the initial bit, u is going to equal 0. Then at some point, or maybe put it there, the velocity would have reached, well, what will it have reached? And we need to remember that we can use SUVAT. So this is page 8 in the formula booklet, all of your SUVAT equations there. And the first one you come across, V equals U plus AT, is going to be very useful here, because the velocity that we get, because we know that the acceleration is 0.6 and we know that the time is 40 seconds just for this first bit. That's going to give us V equals U, which is 0, plus AT 0.6 times 40 is 24, so 24 meters per second at that point there. Then that becomes the new U as such, U being the initial velocity. Then there's going to be a period of time when it's going at a constant speed, so I'm going to put a little dot there for when it gets to that. So that's going to be a constant velocity, so it's still going to be there. And then we're going to have the last bit. Now I'm going to put another U there, but I'm going to do it in a different color so I don't get too confused about it. So we're going to say, right, then at this point U is going to be 24 and V is going to be 0. Now it doesn't explicitly say that the train stops, but it does say it's going between 2 stations and it's decelerating until it reaches the station. You can assume there that it means it's stopping, otherwise we can't really solve all the things that are going on. And the deceleration is going to be at negative 0.4 meters per second squared. Try and ignore my very absorbent paper, it's rather annoying. So yeah, so we've got that during this. What we do not know is what the time is in the middle part. So the time we do not know. We know that the velocity is 24, but we don't know how long it's going on for, so we don't know that distance yet. But what we do know is that between there and there is 4,000 meters. Now, having taken that time to consider what's going on, it's going to be much simpler to draw a the sketch of the velocity time graph. And we're not expected to work out that t for it, but we are expected to have worked that out at that point. So velocity time graph, time always goes along the x-axis and velocity along the y-axis. So the velocity we're going to have on the top, they're both going to start at 0. The maximum velocity is going to be 24, so I'm going to put that in there. Make sure that you label your axes and give them some units, so that's meters per second. And we've got the time here, which is seconds, and the first bit is going to take 40 seconds, and then we're going to have a region that we're calling t because we don't know it, and then it's going to be 60 seconds. So I'm going to sort of represent that by going a little bit longer there. It's going to be 60 from there to there, so I'm going to have to put 60 like that because it's not 60 seconds overall. It's going to be 100 seconds plus whatever t is. And then we need to use straight lines to show this bit. Now it is sketching, so you can do it without a ruler, but it's quite a good idea just to be ultra safe on this. So going up to there, that's going to be constant, and then we're going to go down to there, and that's put everything on that we can do. That's sketched our velocity time graph, and that should be useful now to work out part B. So if you haven't done that yet, pause the video and have a crack at that before watching what I do. I'm going to start by splitting it into 3 zones. Now, as we've got station A and station B, perhaps I should have had that on there before as well, I'm going to call this zone here X, this one Y, and this one Z. And in order to work out the total time, we've got to work out that time. We know it's 4,000 meters altogether. The distance under the line is the area under the line, sorry, is the distance that we go, because distance equals velocity times time. So to start off with, we're going to do the distance x, and I'm just going to use s equals, now there's different ones you can, but I'm going to use s equals u plus v t. In fact, some people do this without even using the things, just looking at this and saying, right, well, this area is going to be 40 times 24 over 2, and that's your half that you've got there. So 40 times 24 divided by 2, which is 480 meters. Then if we do Z next, very similar, we're going to have 60 times 24 divided by 2 is 720 meters. Add those two together and you get 1200. So y must equal your 4,000 meters, take 1200, which is 2,800 meters, and times t. Well, we know that 24t, 24 times the time, must make the distance. So t is going to be 2,800 over 24, which is 116.6 recurring. The question is the total time taken by the train to travel from A to B. So we then need to add the 40 and 60 seconds on. So add another 100, gets us 217 seconds to 3 significant figures. And that's the first question sorted out. So that's question 2. And next we're going to move on to question 4. So pause the video and have a crack at this. Right, so here's our other question, question 4. Go through the same process as before, see where it gets you. Pause the video and then see if you agree with me. So I'm going to start off by making a little sketch again, so that I've got something to visualize exactly what's happening, because we've got 3 stages. There's often 3 stages going on. We're starting from rest. Always take the opportunity to draw a little car. This leaky paper again. It's not a great car, is it? But it looks faster if you draw it not touching the ground. That's what I find. So we've got 6 seconds and then 50. So not very long at all before the first bit. And at that point, we're going at V. And the time taken to get from there to there is 6. And then we're going to have another long zone of time, 50 seconds for that next bit, at which point V becomes U and U becomes V at the very end there, when that becomes 0 when he comes to rest. What else do we know? We know that the acceleration at the beginning is, what's the acceleration? It goes at a constant acceleration. That's all we know. And then we know that at the end the acceleration is 1.5 times the magnitude, but it's negative, so it's going to be negative 1.5 a there. And we've got to show that the total time for the journey is 60 seconds. So the t for the last part here is the bit that we've got to work out. Now, acceleration, how do you work out acceleration? Well, acceleration, part A, acceleration is velocity divided by time, isn't it? So let's do it for both these situations. For this situation here, our acceleration is equal to the velocity divided by 6. And therefore, we can say that the velocity is equal to 6a. Now, what about at this stage here? We can say that the acceleration is 1.5 times the size, isn't it? We're not bothered with whether we're getting faster or slower. It doesn't really matter. The rate of change is going to be the velocity divided by the time, however long that takes. So if we just rearrange or multiply by t, we can say 1.5 at is equal to v. Now we've got both these v's being the same, defining them in a slightly different way, so we can now say that 1.5 at is the same thing as 6a. We can divide, we can divide by 1.5a, and that gives us 4, and therefore that is 4 seconds, and we can say 6 plus 50 plus 4 equals 60 seconds, and we've definitely shown that. Okay, so that was that bit. Now, sketching the velocity, in many ways, I think that was probably the trickiest part of the whole question. The velocity time graph comes next, and so we just need to show that we're getting up to the velocity, whatever that is. We still need to say that velocity is meters per second, starting from 0. We've got a bunch of time going along here. We've got time starting at 0, going up to 60 seconds. We've got a pause at 6 seconds and 4 seconds before the end, so that's at 56, and we can say that that is time in seconds. Then we just need a straight line going up to there, straight line going across to here. You can put a little dotted line there if you like. and then a straight line going down there. And that is our sketch for our graph. Now we're going to use this for part C to work out what the speed is, or velocity, because we're told the distance is 1,320 meters, and the distance is the area under the graph, isn't it? So I'm going to call this region A, region B, and region C, and I'm going to say I know that A plus B plus C is equal to 1,320 meters. And then I'm just going to define all my different parts. So A is going to be, well, it's base times height divided by 2, isn't it? So it's going to be 6 times V divided by 2, which is 3V. Part B is going to be from 60 up to 56 is 50 seconds. 50 seconds times the velocity is just going to be 50V. And part C, well, that's 4 seconds for the base. The height is V again, so 4V over 2 is 2V. So we can say that A plus B plus C is equal to 55V, because 3 plus 50 plus 2 is 55V, and we know that 55V, 55 times the velocity, is equal to 1,320 meters. So then all we have to do is divide 1320 by 5, and that gives us exactly 24 meters per second. And that is that. So I hope you got on okay with that. Remember to upload your evidence to me and let me know if there are any places in the other 2 questions where you get stuck, or if there's something you disagree with in what I've said here. All right, folks, cheerio.